Hi everyone, this video is showing you how to calculate the ground state energy and ground state energy of a simple molecule using the program called CM Quantum. So what we are going to use in this video is the program CM Quantum itself, which is contained in this folder. The SQ here is the CM Quantum. So CM Quantum is a program that doesn't support the graphic user interface. So when we try to run the program, you can see that the program immediately disappears. So in order to run the program, we are going to use the command prompt or the text user interface. So if I double click on the command prompt and type sq.exe, so this is what the program looks like. Okay, so now we are back here and we're trying to build up a molecule using the software called Avogadro. Okay, so if you double click the Avogadro, it will show you a window. And then let's say if I want to simulate a water molecule, okay, so I choose oxygen over here and I do one click. Okay, it will give you the structure of oxygen atom connected by two hydrogens, which is the water. Okay, and then I would save this coordinate. So I go to save as, and in the SQ folders, in the CM Quantum folder, I name the structure as water.xyz. So there are a lot of file format, but today we're choosing to use xyz, and then we save it. Okay, so what you got from here is you are having an xyz coordinate file called water. So if you open this by Notepad, what you can see is you're just gonna see the first line with the total atoms of the system. For the second line, it can be anything. The program won't read it, and you can see the next lines with the coordinate for each of the atoms. Then we're now using CM Quantum to calculate it. Okay, so let me just close the Avogadro, and then we open the command prompt. Okay, and if we type dir, we are seeing everything, every file within the folder. So dir is the showing directory command in the command prompt. And now if I run the program, so sq.exe, and then followed by the structure, which is water, and followed by the basis set. Okay, we are now choosing 321G. Okay, and I want it to output the density for us, and push enter, so the calculation finish and the density profile is written in the volume XSF. In order to visualize this file, we need the VMD software. So we click and open it, and then we just drag the result from the calculations to be displayed in VMD. Okay, so you can simply drag the volume.xsf to any of the VMD window in order to create a new molecule. Okay, I just overdid it, so I can delete the molecule also. Okay, so now we have the structure of water molecule. So if we go to graphic representation and try to change the rendering method to CPK, so you can have the better looking molecule with three-dimensional structure. And then we come back to the graphic representation window and we click Create Rep to create another representation. And on that representation, we are going to change the drawing method to isosurface. So you can see that when you open the isosurface, it looks like your molecule is within the box. And if we adjust the ISO value to, let's say, 0.1, you can see such a density profile for the water, okay, in which you can render it as points, wireframe, as a solid surface. Okay, so let's get back to the wireframe stuff. Okay, and now if we look at the structure, so you can see that the electron density profile has a very high value around the oxygen. That was because the electronegativity of the oxygen. And if you come and have a look at the result, okay, you can see that the molecular charge was calculated, and the charge calculated for oxygen is lower than one, much lower than 1 electron. And for the H2, the charges is positive because the some probability of the electron was stealed by the oxygen.